Hey you guys, in this video we're going to talk about references as they are a concept that is introduced in C++ and how you can use them to your advantage. So let's start with an empty program. So to create a reference variable, I can do something like this. And this looks, well, quite different. So in your experience with C, you have seen the declaration and initialization of variables without the ampersand or with an asterisk. And if it doesn't have anything, so if it's something like this, we've just created a normal variable. But you have seen variables that are declared this way, which means that they are a pointer. So here x is a pointer to an integer, while here x is just an integer. And now with C++ and with the introduction of references, x is a reference to an integer. So what does it mean to be a reference? Well, it's kind of like having a copy of a dereferenced pointer. So when dealing with pointers, they just contain their addresses, and you need to dereference them if you want to edit the value there. With references, that layer of dereferencing is taken away. So this kind of means that you kind of have a pointer, but it's already being dereferenced. So for you to modify it, you just need to modify it. You don't need to dereference it because it's like already dereferenced. One thing that I always will say though, when you have a reference like this, it needs to be given a value. If it is not given a value, it is a syntactical error. Your compiler will complain to you that, hey, this reference needs a variable. And let's change this up. Right, so these ways are valid ways of creating references. One other thing that I want to say is that when you have a reference to a variable, you can't have it refer to something else. And actually, this first line is wrong. This is really the way of going about creating references. Right, so this is correct, and let's label it as such. But incorrect would look like this. So the incorrect ways of creating a reference is just by trying to declare a reference by itself, or trying to change the original reference of a variable to something else. So here, when I create a reference, is that this can only be bounded to y. And that's the only variable that it can be bounded to. It can't be a reference to any other variable. So how can we go about using references? Well, it takes a layer and it makes it easier of using pass by reference functions and methods and variables. So here's an example of using one of the more famous functions, swap. And here we are. So the first function that I created here, I named it cswap, and it takes two inputs, a pointer to an integer called x and a pointer to an integer called y. So now let's run through the body of the code. Here I create an integer called temp, and I dereference x to get the value of x, and I store it into temp. And then here I dereference x and I give it the value of the dereferenced y. So in doing this, I have permanently changed the value of x from where the function's called. And because of this feature, this is a function that is passed by reference. Because in this line, well actually 6 and 7, since I'm editing both of these and they're pointers, the function that called this, here it'll be in main, they will be edited as well. So if I go down here, and actually let's change the two variables here so we don't have any confusion. So we have a and b here. When I pass it to swap, well, I need to give the address of a and the address of b so that we satisfy what a pointer requires, which is an address. But here when I edit x and I edit y, I'm actually indirectly editing a and b. So why don't we see the result of calling cswap? And here we see that the results are swapped. But this is more of the C way of doing things, which is why I called the function cswap. And this is a review of how typically swap works. So now let's go about using C++, and I'll just say swap a and b. And we will print the result here. And let's just see what happens. Whoa, it acts just like the C swap. Editing those values there permanently edited the input arguments that I used when I called the function. What does that mean? Well, here I just put swap A and B. I did not put their addresses. So in terms of C, this looks like something that's passed by value. However, because in C++ now, swap here, it takes a reference to an integer, well, called x, and a reference to an integer called y. This is also now passed by reference, but now these variables are like in permanent dereference mode, meaning that when I edit it here, and when I edit x here, and when I edit y here, since they are already like in permanent dereference mode, I permanently edit them because they are references to the variable here. So it's analogous to using a pointer, but when you use them in a traditional sense, it's already dereferenced. And this is quite a neat upgrade because this feels more, I guess, normal in terms of interacting with variables in general. Right here, there's a clear difference that you're doing something extra or something special, something that you may need to keep track of, and this can become, a pain. But here, this looks a little bit more intuitive. It's just like these variables are normal variables and whatever. But in reality, there are already dereference pointers, and we are indirectly modifying the values of the inputs here. So putting swap here and using these inputs, because it takes an input as a reference and thereby making this function pass by reference, I'm editing A and B when I edit x and y here. Why don't we do another quick example but with a vector? And here we are with the example. So let's start off with this first function here. So here I have print vector, and it's a const stood vector float, and it's a reference to v. So, I mean, here this looks a little bit counterintuitive because I'm taking a reference to a vector, but I'm not treating it as const. Print vector is a pass by reference function. However, I'm putting a const here, so I can't edit this. And this is an additional safeguard. So using pass by reference functions and using pass by reference in general, this actually saves memory. Because if this wasn't passed by reference and I didn't have this ampersand here, I would be taking a copy of the input. And let's say, well, here the example is very small, but if this was a vector that had 18,000 values, taking a copy of an 18,000 value vector, that'll cost you some time. But if you have a reference to it, you're getting that vector itself. But again, incorporating the const keyword here means is that while we have access to the vector itself, because it's const, we're safeguarding ourselves from accidentally editing it. And I even do an additional const here just to be safe when I do this range-based for loop to iterate through the entirety of x. But then that brings us to our second function, multiply 2. So this doesn't have a const. It's stood vector float, and it's a reference called vect. Like print vector, this is a pass by reference function. But because I don't have the const here, if I edit vect, it's going to indirectly edit the input that I gave when I called the function multiply 2. Right? So the argument that I put into multiply 2, if it's edited inside of the function, that argument's going to be edited. And here I have another range-based for loop where I don't have that const, and it's a reference. So if I edit x here, this is going to permanently edit the contents of vect. But for this function, that's exactly what I want to do. I want to multiply by 2, and I want to multiply every single element, the full range of vect, by 2. So, well, I need to change this misspelling. But here's the program. I have a few floats. I have 5 floats that are in this vector called t. we're going to be printing the vector, we're going to be multiplying its contents by 2, and we're going to be printing it again. So why don't I fix my little typo, and we'll run this program and see the result. And here we are. And because I use something called, well, an initializer list, which is this, I need to put the standard flag on my compiler here, the standard C++17, so that I can compile this code without any errors. But again, let's take a look at this code. So here I have my original vector. This is good. This is exactly the variable and the data that I provided, and it is correctly printed. But then I run my multi-by-2 function, and I print my vector again, and it looks like it is all multiplied by 2. That every single element inside of my vector that I gave as an input is multiplied by 2. And this is a nice useful tool, because with these functions, in the entirety of all this, oh wow, that's bright. But the entirety of all this, I'm only really dealing with one vector. If I didn't have these ampersands here, I'd have to take copies of them, and I'd actually be creating 3 vectors in total. So using references is one way of saving space in your program, and it gets you some pretty good benefits of pass by reference. If I didn't have references, I'd have to use this as a pointer, and then I'd have to go about dereferencing the pointer, making sure I'm dereferencing everything correctly, and that kind of thing. And that's just extra work. With the introduction of references here now, some of that work gets easier for us, and this looks more like how we would interact with, traditional variables. Right, if it was just like an integer or a float, that kind of thing. It makes it easier to work with. Thanks for listening on this video on references, and I'll see you on the next.